So now let's talk about the definition of an ellipse. So you see, an ellipse is the set of all points, so all those guys around that shape, the ellipse, x's and y's, in a plane, the sum of whose distances from two distinct points, the foci, is constant. So if I take this focal point and this focal point right here, and I measure to a particular point xy on the ellipse, this distance d1 and distance d2 from those two focal points, when I add them together, will always make the same number. So d1 plus d2 is constant. So with that in mind, we have to think about how these other things take shape in ellipses. So if we talk about an ellipse, the line through the foci intersects the ellipse at 2 points, right here and right here. Those 2 points are called vertices. The chord joining the vertices, I'll go ahead and draw it, is called the major axis. So that red line that I just drew is the major axis, and its midpoint is called the center of the ellipse. The chord perpendicular to the major axis at the center is referred to as the minor axis. So that's what's being drawn down below. But the important thing to recognize is that the focal points help you identify which of the two axes is major axis. So here the major axis is horizontal and the minor axis is vertical. You can visualize the definition of an ellipse also by imagining two thumbtacks placed at the focal point as shown in figure 4.24. If the ends of a fixed length of string are fastened to the thumbtacks and the string is drawn taut with a pencil, notice what you get. The string is constant, so this length plus this length will always be the same length. And so when you do that and you draw, making sure that the string is always straight, the pencil will sketch an ellipse. So that's from a concept standpoint. Let's talk about the standard form of the equation of an ellipse. If we talk about the standard form of the equation of an ellipse, it takes one of two forms depending on whether the major axis is horizontal or vertical. So let's talk about it here. Standard equation of an ellipse centered at the origin. The standard form of the equation of ellipse centered at the origin with major and minor axis have lengths of 2a and 2b. So 2a is the length of the major axis and 2b is the length of the minor axis. Now let's see how this works with the equations. Here on the left we have x squared over a squared and y squared over b squared. Now here's something that's really important too. In talking about an ellipse, a is always going to be larger than b, and b is always going to be greater than 0. So keep that in mind. So when we have x is over the larger number a squared plus y squared over b squared, and that equals 1, that is the standard form for the equation of an ellipse that is wider than it is tall. So actually this is what it looks like right here. Notice this ellipse here is centered at the origin, and it is wider than it is tall. So from negative a to positive a, comma 0, that is the major axis, and the focal points are the distance c. Now, I want to also identify for you c. The vertices of the foci lie on the major axis, and a and c units, so respectively, from the center as shown in figure 425. So here's figure 425. The distance then that's being talked about from the center to C, that is the distance C. the distance from 0 to the vertex is little a. And so without going into the details of how to get there, we want to make sure that you understand that a, b, and c have this relationship about them where c squared is always equal to a squared minus b squared. Seems kind of Pythagorean, but it's got a minus instead of a plus, and there is a relationship there, and we can develop that later. But let's go to now also talking about this idea here where this ellipse is taller than it is wide. Well, that's the ellipse where the standard form of the equation then is x squared over the smaller number b squared plus y squared over the larger number a squared is equal to 1. So there's the two forms of the standard form for an ellipse, and let's go ahead and try to solve here example 3, finding the equation of an ellipse. So find the standard form of the equation of the ellipse that has a major axis of length 6. So that's talking about from here to here is a length of 6. So doesn't that mean if this is at 0, 0, that this point right here must be negative 3, 0, and that makes this point right here 3, 0. And so there we have some points there. Well, we've already been told then that the major axis is equal to 2a, so we can say then that 2a is equal to 6 because the major axis is 6. And the focal points are c from each other, so we can already say then that c is equal to 2 because each focal point is two points away from that. We've also been told that the relationship of c squared to a squared and b squared is c squared is equal to a squared minus b squared. Well, we know all this stuff. So we have c is 2, so 2 squared is equal to 3 squared, because when we divide both sides by 2 here, we get a is equal to 3, minus b squared. B squared is the only one that we don't know. Well, this is going to be 4 is equal to 9 minus b squared. So if I subtract 9 from both sides, I get negative 5 is equal to negative b squared, and divide by negative 1, I get 5 is equal to b squared. So b then is equal to root 5. So the distance to b is root 5. So finding the equation of the ellipse, well, we know then that if this is the case, then b squared is equal to 5. And we know that a squared is equal to 9. And we know that c squared is equal to 4, which is not important in writing this, but they're asking for what is the equation of this ellipse. Well, we know that this is wider than it is tall, so it's going to be x squared over 9 plus y squared over 5, and that's equal to 1. And there we have it. That is the equation of that ellipse on the right. For example 4, we're going to be sketching an ellipse now. And here we're starting off with something that says 4x squared plus y squared is equal to 36. Well, we need to have that right side be equal to 1 in order to be in standard form, so we're going to divide everything by 36. And watch what we get. 4 and 36 have a common factor, so we're just going to take that out, and that becomes x squared over 9. And we have plus y squared over 36. And that's equal to 1 now. Well, if we turn these into square forms, which it's very convenient to have this here, we already know the length of a and b. And so watch what we do. This is going to be x squared over 3 squared plus y squared over 6 squared. Well, doesn't that identify that this is A? And that then identifies this as B. So if A is 6 and B is 3, then we know that the center of this ellipse is at 0, 0, and we can go 6 up, 1, 2, 3, 4, 5, 6, and 6 down, 1, 2, 3, 4, 5, 6, and we've identified the vertices of our ellipse. Let's go ahead and find the axes that are at the end of the minor axis. Let's go 3 to the right, 1, 2, 3, and we're going to go 3 to the left, 1, 2, 3. Now, we don't know what the focal point is, but we could just calculate it. It's going to be c squared. We'll do that in yellow. C squared is equal to 6 squared minus 3 squared. So 6 squared is 36 minus 9. That's going to be 27. So c squared is 27, so that means c is going to be the square root of 27. 27 is 9 times 3, so isn't this just going to be the same as saying 3 root 3? So 3 root 3, well, it's somewhere, isn't it? 3 root 3 is 3 times about 1.7. So it's going to be more than 4. 1, 2, almost 5-ish. And there's the focal points. So there we are. And then we can draw our ellipse. So try to stay nice and curvy when you do it, when you draw it. And there's our picture of an ellipse. Don't close it off too quickly. So kind of sloppy, but there it is. And that's how to sketch an ellipse. All right, I've given you in the examples lots of things to consider, so you might want to watch this over again. But here is our homework. I want you to be doing page 367. There's 17 problems made up of 1 and 3, and then 11 through 27 odd, and 35 through 45 odd. And so good luck on that. And if you need help, come see me during study hall.